This video is about continued ratio, proportional distribution, and two values that change. Okay, this is about continued ratio. Continued ratio is the ratio that consisting more than two ratio. So let me give you an example. There is a problem. This is all about pocket money. Pocket money for three guys, three boys. Okay? There is Mr. A, Mr. B, Mr. C. Okay. In the question, the ratio of each couples are given. So the ratio of pocket money for Mr. A and Mr. B is 3:4, and there is another ratio is given. The ratio of pocket money of Mr. V and Mr. C equal 5:6. So the question is, what's the ratio of Mr. A to B to C? Okay, let's solve it. So there is a tip for solving this type of question. The tip is, since Mr. V is found, Mr. B's numbers is found in the both ratio, you standardize the value of V to the ratio of these three guys. What does it mean? Okay, let me give you an example. So ratio of A to B is 3:4, and the ratio of B to C is 5:6. So as you can see, the number of the V is shared in the both ratio, right? And you just standardized the B. So, but the value of the B in the both ratio are different. So it's time you bring up the least common multiple. Okay, what is the least common multiple of 4 and 5? Which is 20. So we make this column to the 20 so that we can connection. Okay, so this column becomes 20. B became 20. So we have to modify the remaining numbers. So the 3, which is from A, should be divided by 5. Okay, so let me say, here's a new one. So 3 times 5 equal 15 to 20, because this is standardized one, and another one, B times C equal 20, and the 5 was multiplied by 4, so remaining 6 should be multiplied by 4 as well. So 6 times 4 equal 24. Now you can see the ratio that is continuing. Okay, so as a result of this procedure, you can express this ratio, Mr. A at the ratio of Mr. A to B to C equal 15 to 20 to 24. So the key of solving this type of question is standardized the shared value in between two ratio. Okay. Okay, this is about proportional distribution. Proportional distribution. Okay, to explain what it is, let me give you a problem. Problem is, there is two boys, Mr. A and B, and they bought a magazine, that cost 450 yen, and the ratio of each of them paid is 5 to 4, at the ratio of 5 to 4. So Mr. A paid 5 while Mr. B paid 4 in the ratio of this one. Question is, how much money did each of them pay for? Okay, let's solve it. So if Mr. A and B paid for 5 to 4, so the ratio of 5 to 4, the whole is 5 plus 4 equal 9. So whole is 9, right? The ratio of whole is 9. Therefore, Mr. A paid 5 over 9, 5 divided 9, 5 ninths of whole, while B paid 4 ninths of whole. So if I take a diagram of this one, let me see. This is 450 yen, and 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So ratio is something like that. So the 5 ninths is paid by Mr. A, while 4 9 B, right? Therefore, the calculation should be like this. Operation must be something like that. The amount Mr. A paid is 450 yen times 5 ninths equal 250 yen, while B paid 450, which is a whole, times 4 ninths equal 200 yen. Yeah? So if you sum up the 250 and 200, 450, right? So this is the same as a whole. Okay, let's do our the two numbers that change. Okay, let me give you an example so that I can explain you are very easy. So there is a problem. How many kilometers do you make progress when you walk 4 hours at the speed of 4 kilometers per hour? Okay, so you walk 4 kilometers, okay, and the velocity is 4 kilometers per hour, okay. So question is, how many kilometers do you move on? Okay, X. Okay, so let me make a table about this relationship. So okay, this is time. Upper column is time, lower column is distance you walked, distance. So time is h, distance is kilometer. So when you spend 1 hour for walking, you move forward 4 kilometer because of this relationship. It is given, velocity is given in 1 hour 4 kilometer. Okay? And when you walk 2 hours, the distance you made is 8 kilometer. When you walk 3 hours, distance you walked is 12 kilometer. And 4 kilometer, which is from the question. When you walk 4 kilometer, the distance ends up 16 kilometer. Okay? So the 16 kilometer is answer, obviously. And I didn't want to explain this kind of things. What I wanted to explain is this relationship. As you spend time 2 times, the distance become 2 times as well. And as you spend 3 times of time, the distance also becomes 3 times. Likewise, when you spend 4 times, when you walk 4 times, distance also become 4 times. As you can see, this multiplication is the same, right? So let me describe in other way, okay? If you walk, this is Japanese. If you walk 1 hour, you walk 4 kilometer. So the ratio is, let me express in a ratio. Ratio is 1 to 4. Okay. This is time. This is distance. Okay, move forward. When you walk 2 hours, distance become 8 kilometer. So the ratio is 2 to 8, and always you always simplify it. So it is divided by 4. So no, it is divided by what? 2, right? So ratio becomes 1 to 4. Same. If you walk 3 hours, distance becomes 12 kilometer. So the ratio is 3 to 12. It is divided the common divisor, greatest common divisor is 3, isn't it? So 1 to 4, the same. And for our 16 kilometer, so it is expressed as 4 to 16, and the greatest common divisor is 4, right? So 1 to 4. So the ratio never change, as you can see. Therefore, just a moment. Therefore, the relationship between the time and distance it's not changed, does not change, is called proportion. Okay, this is called proportion. So as you can see, the ratio of each relationship never change. In this case, we name as proportion. So back to our original problem, we say time and distance is proportion. That's it.